On the battlefield of the future, information will be the ultimate weapon. Ground, air, and sea personnel will rely on the collection and instant exchange of intelligence to achieve critical objectives. Satellites and UAVs will instantly relay reconnaissance images to ground platforms, and targets will be addressed with pinpoint accuracy. This is the concept for the NetCentric battlefield. I'm Joe Aragona with the Business Report. Many companies in the defense and aerospace industry are working on different components that will turn the NetCentric battlefield into reality. Curtiss-Wright continues to lead the industry with a new product that will enable it at the platform level.
Well, there are really two primary trends that are driving the need for switched gigabit Ethernet within military platforms. One of them is Department of Defense's NetCentric Warfare, which requires the connectivity of platforms in the battlefield. And the second is DoD's mandate to use IPv6 as the unifying communication protocol between those platforms. The main thrust of what's happening is it's creating intra-platform networks, or what I call IPNs, within the core of every single air, land, and sea platform. This is being done by connecting multiple single-board computers and digital signal processors through Layer 2 and Layer 3 gigabit Ethernet switches. It's really a natural fit. The 680 Switchblade, our flagship product, is providing system integrators with a quick and simple way of creating intra-platform networks within their subsystems as well as their complete system. The 680 Switchblade is being used in multiple ways, and this really depends upon the customer's topology and application. So the typical topologies that are being used by customers include star topologies where each end node is connected into the switch. There's extended star topologies where multiple switches are cascaded or stacked together to form larger networks. There are dual star and mesh topologies also that facilitate redundant networks.
Martin Cassels of Curtiss-Wright says there were some design challenges and considerations for the design team working on the 680 Switchblade.
When we designed the 680 Switchblade, we looked for the best-in-class technology. This has got software and hardware components. Basically, from a hardware perspective, we were looking for something that was highly integrated, low power, would fit into a single slot of a VME chassis, had to have multiple protocol software support, and was also expandable. We wanted to be able to stack switches together, so having a 10 gigabit stacking port was important to us. We designed it with ruggedization in mind, so we incorporated derating in our design. The components themselves, we looked for industrial level components. We did COTS analysis on components, any ones that weren't available in a rugged form. Then the actual qualification itself, we exercised the switch using smart bits in a network test, in a mesh test, to fully stress the switch. At the same time, we shook it on a single axis shaker for shock and vibration testing. And we put it in a temperature chamber and a conduction cooled test fixture that minimizes convection and radiation for the conduction cooled testing, and then an airflow fixture for convection cooled testing. The design goal of 24 ports was really our objective. However, not only have you got to accommodate 24 ports at the back of the switch, but there's also the control signals we had to accommodate. There's a serial port that's available for configuration. There's another Ethernet port that's available for software upgrade in the field. And there's a reset signal as well. Now the reset signal, we could have used the VME sys reset signal. However, we regard the 680 as more of a system card rather than an individual card like a single board computer. The single board computers may in fact be booting via the 680. So for that reason, we separated out the reset signal, and system integrators can reset the card as they wish. That leaves the gigabit Ethernet signals to be routed. Gigabit Ethernet has 4 pairs per interface. So we were able to route 11 gigabit Ethernet interfaces on the P2 connector and 9 on the P0 connector to a total of 20. The other 4 Ethernet interfaces we regard as special, and we have configurable razor blade modules to allow versatility of the product. There's different flavors. There's one flavor which provides you with 4 gigabit Ethernet RJ45 connectors on the front panel. There's another one which provides you with 4 10100 interfaces at the back plane. Now the 10100 interfaces, because that only requires 2 pairs of signals per interface, we route those to the reserve pins on the P1 connector. We recognize that some customers can't use the P1 connector reserve pins, but they're available there, so we've made use of them if the customer requires. Another version of the razor blade provides with 4 fiber optic interfaces. Fiber optic interfaces are traditionally done using full duplex LC connector modules mounted on the front of either the base card or a mezzanine. Now these require the LC connector, which is, it's a plastic, it's not a very rugged connector. We have concerns about using that in the rugged environment. Also, the back shell of those connectors extends like an inch or an inch and a half, and then there's the bend radius of the fiber optic extending behind them. So the chassis lid can't be closer than about an inch and a half, 2 inches from the card front. We looked for an alternative solution, and Stratus Lightwave have available transceivers with integrated pigtail fiber optics. We mount those on the razor blade board, and we bring them through the frame with a curved groove in the frame that supports the fiber optic through the frame, such that it restricts the bend radius to which is typically a 1 inch limit, so we don't kink the frame, we don't kink the fiber optic. Also, the fiber optic itself leaves the card in the plane of the card front, actually sitting on the card front. So the chassis lid can actually sit right up, almost in contact with the lid of the front of the card. The fiber optics themselves, we then anticipate the system integrator will route across the card fronts to a row of bulkhead connectors. These can be rugged connectors like FC connectors. We recognize that system integrators have different levels of networking experience. So for the new users of these sort of products, we try to make the out-of-the-box experience as simple as possible. Basically, the product comes totally integrated. There's a base card with the switch devices on it. There's a separate processor mezzanine that's plugged in, razor blade expansion module if required, and an LED display, all integrated into the single slot product. For a conduction-cooled card, the LED module is actually a separate plug-in, which is available for debug purposes if required.
The key to network design is configuring specific protocols to meet network objectives. Nauman explained how users configure those protocols with the 680 Switchblade.
Configuring the software on the 680 Switchblade is really easy to do. So for novice users that simply want to create layer 2 switching, they just need to plug in the switch, wire up their system, and the switch will be ready to forward right away. For more advanced networks, users can actually get into the switch using a command line interface, a telnet interface, a web interface, or even a standards-based SNMP interface, and configure the appropriate protocols as required per their application. Just about every protocol is being used in the 680 Switchblade by different customers, but some of the more frequent ones that come to mind are VLANs, which can be used for secure segmentation of networks. There is port mirroring that can be used for data recording applications. Link aggregation can be used for higher bandwidth networks. At layer 3, there are protocols like IP multicasting that can be used for intelligent broadcasting of messages to subscribed users. There's also dynamic routing protocols such as RIP and OSPF. And then finally, customers are also using ACLs or access control lists to create stateless firewalls for secure network operation.
The configuration software incorporates an extensive built-in test suite. We have power on bit with a 95% coverage, an initiated bit, and background bit. We also have a declassification feature, which is used to wipe any sensitive material off the switch. We regard the sensitive material in a switch could be the configuration settings that the system integrator had. It could be statistics on the data that was passed through the switch. So when the declassification command is used, the configuration is removed and a default configuration is restored.
Ultimately, the 680 Switchblade has to fit in with specific interconnects and standards that are out there. Nauman explained how.
Gigabit Ethernet switching is really a nice complement for other fabrics, whether they're legacy fabrics or interconnects like 1553 or next generation fabrics like Serial Rapid I/O, PCI Express, or ASI. It provides a natural fit as a control plane and even as a data plane in some cases. It's a complement to higher switch fabrics, and eventually when 1 and 10 gigabit Ethernet is eventually used in the backplane as a core switch fabric, that will facilitate all IP and gigabit Ethernet networks.
It used to be that gigabit Ethernet was very limited by the processing required for the TCP stack and by the host processor. Nowadays we now have TCP offload engines or TOEs available. These are PMC cards, or they might be on the host card, and they're available for 1 gigabit or 10 gigabit Ethernet. And basically now the roadblock is no longer the processor capabilities, it's more the bridge device that's being used in the design. This is a limitation that all interconnect technologies have. So really, Gigabit Ethernet is really on a par with these other technologies.
Well, there are multiple driving requirements for the next generation product, which include 10 gigabit Ethernet links for high-speed backbones, full IPv4 and v6 wire speed capability, encryption protocols, as well as stateful firewall capability.
With its speed, features, and unique design elements, the Switchblade and Fireblade are poised to bring the NetCentric battlefield one step closer to reality. They address the communications needs of the platforms of the future. For the Business Report, I'm Joe Aragona.